Here I am going to discuss about addition of two 16-bit numbers. Before writing the program, we will draw the flowchart of this. Here, while starting a flowchart, first step we have to draw we have to start the program. Okay, for that I have drawn start, and after that I will clear the accumulator document. Okay, whatever the document in the accumulator, that I will clear. And now I want to load the two 16-bit data from the memory. So that first I will load the first 16-bit data into HL pair. Now I want to store the second data. To store the load the second data, I want to move the data of HL pair into DE pair, and after that again I will load the second 16-bit data into the memory, that is HL pair. Now we are having data in the DE and HL pair register. Now we have to do the addition, and for addition 16-bit data I will add the data of DE pair and HL pair, and I will store the data into the HL pair. Okay, after addition we will check if any carry is present. If any carry is present, then the carry flag will be set, so that I will check the if is there any carry. Okay, for that I will check for carry. Now if any carry is not present, then directly we will store the data into output memory location. If is there any carry, then we will increment the first we have cleared the content of accumulator. To indicate the carry, we will increment the accumulator content, and then we will store the data of HL pair into the memory, and after that we have to store the content of accumulator also into another memory location to indicate the carry. Final step of this program is we have to stop the program. Okay, after store data memory, we will store the accumulator data into the another memory location, and final step is we have to stop the program. Okay, this is the flowchart of the program for addition of two 16-bit numbers. Okay, now if I am storing the two 16-bit numbers in the location 4200, 4201, 4202, 4203. Now in 4200 I will store, if I am storing data 05 in 42005H, okay, we will represent this in the hex, and this will be 04H, this will be 03H, and this will be 02H. Now in the first instruction I will load this data into HL pair, and second I will load this data into the HL pair. Okay, now we will start the program. After starting, first we have to clear the accumulator. For clearing accumulator, I will load a data 00 in accumulator directly. For that I am using the instruction MVI A, 00H. That means now the content of accumulator will be 00. Okay, after that I will load the content of this memory location into HL pair. For that I have an instruction LHLD 404200H. This means that the content of 4200 that will move into L register, that is 05H, and content of 4201, that is 04H, that will move into H register. Okay, now I want to move this data into D register. That's why I will use the instruction XCHG. What do you mean by XCHG? In XCHG, whatever the data present in the HL pair, that will exchange to DL pair. So that now the data in the DE pair, the E register contains 05 and D register contains 04. That means the HL pair data will move into DE pair. Okay, Now I want to load again the second 16-bit data. So that I will use LHLD. Now 4200 and 4201 data I have already loaded. Now I want to load 4202 data. After execution of this instruction, the content of L register will be 03H and content of H register will be 02H. Okay, now we are having data, one 16-bit data in DE and one 16-bit data in HL pair. Now we have to add these two data. For adding these two data, 16-bit data, we have an instruction that is DADD. This means that it will add the content of HL pair and DE pair and the result will be stored in this register. Okay, for that, see how we will add. We will see the operation. See here, in the DE register, what is the content? 04. 04 we will write in 16-bit representation like this, and then next 05, that we will represent 0, 0, 0, 0, 1, 0, 1. Okay, this will be 04 and this will be 05. Okay, this is the DE pair that we will add with HL pair. What is the HL pair content? H contains 02, that is 0, 0, 0, 0, 0, 0, 1, 0, and L will be 0, 0, 0, 0, 0, 0, 1, 1. Okay, now we will add these two data. When 1 1 0 0 carry 1, 1 1 0 0 carry 1, 1 1 0 0 carry 1, then 1 here it will come, then 0 0 0 0, again 0 1 1 0 0 0 0 0. Okay, that means this is the data. This is one 16-bit data and this is another 16-bit data. This represents 08 and this represent 06. Okay, and here this will be the, this is the 15th bit. Now this 16-bit will be 0. There is no carry, so that the carry flag will be reset condition. Now see here, now we have added, now we have to check for carry. Okay, for checking carry we are using the instruction this one, jump if no carry to skip. Okay, means if there is no carry it will go to skip loop. Okay, this we are representing a loop, and if there is any carry, if is there any carry, then here will be 1 and carry flag will be set to 1. Okay, carry flag in the processor. So that what we will do, we will because initially we have set accumulator 0 0, then we will increment the content of accumulator. Okay, that's why we are giving INR A. Now after we are storing the accumulator, or if there is no carry, then what we have to do, we have to store the data of HL pair into one memory location. For that we are using the instruction SHLD, then location we will give, that is 4300. Okay, here 4300 we are using for storing the output data or after addition, and that's why whatever the data in the L pair, that means 08, that will move into 00, and whatever the data in the H, that will move into 4301 memory location. Okay, and after that we have to copy the data of accumulator into next location to indicate the carry. Now here accumulator there is no carry, that's why after this step it directly come here, and for to store the content of accumulator into using the instruction STA, we will store the data into 4302. That means whatever the content in the accumulator, that will store. And final step means we have to stop the program. For that we are using the instruction HLD. Okay, this is the program for addition of two 8-bit numbers.